Hi students, in this video we see few more properties of the transform. One of the important property is time expansion. Time expansion property of the transform. What it's telling, if the transform of x of n is x of z, then the transform of the transform of x of n by k is x of z power k. This is what time expansion property. So what you have to prove? The transform of x of n by k is x of z power k. Let us prove. So what is that? I want to find the transform of x of n by k. That is given by x of n by k z power minus n, where n goes to minus infinity to plus infinity. I substitute in general formula. So here I need only single variable because the format is x of n z power minus n. So I want to convert it to single variable. So I replace let n by k is equal to l. This implies n is equal to k. I want to write everything in terms of l. So here n varies from minus infinity to plus infinity. This implies when n is equal to minus infinity, l is also minus infinity. When n is equal to plus infinity, here l is also plus infinity. So I convert this equation number 1 in terms of l. So x of n by k. So when n is equal to minus infinity, l is equal to minus infinity. N is equal to plus infinity, this is also plus infinity. X of n by k is l z power minus n is equal to kl. So kl. Okay. So what I am going to write, so this one can be written as summation n goes to minus infinity plus infinity x of l z power k minus l. So that is equal to x of z power k. Why? You see, we know general format is x of z is equal to summation x of n z power minus n. Here n. Here you see l. So n, l, here also l. So this one is z. So this z power minus n I write as z power minus 1 z power minus n. So you see this is the formula. So x of z, whatever be inside this bracket, that will come here. So inside the bracket is z power k. So I can write as x of z power k. That's what we have to prove. So x of n by k is x of z power k. Right? So that is the z transform of x of n by k. Hence proved. Right? So that's one of the time expansion property of Z transform. And a few more property we have to know is, for that we don't need proof, but we must know complex conjugate. Complex conjugate property of Z transform. What is telling? If x of n, x3 of n is equal to x1 of n multiplied by x2 of n, this implies x3, that is the transform of this one, is given by 1 by 2 pi j closed integral x1 of b x2 of z by b into a inverse dv. This is complex conjugate to the property of Z transform. And one more property is Parsevals Theorem. Parsevals Theorem of Z transform is given by summation n goes to minus infinity to plus infinity x1 of n x2 of n star is equal to 1 by 2 pi j closed integral x1 of b x2 star 1 by V star into D. This is Parsevals theorem of what you call Z transform. So just you remember this, no need to prove. So these are all the properties of Z transform. I hope you understand. If you have any doubt, please ask me in the comment section. Thank you.